Hi friends, this is Shubham and welcome to my YouTube channel. So in this video we'll be talking about a problem in PCA, that is principal component analysis. Okay, so what it is used for dimensional reduction. It is basically a dimensional reduction technique that we used to reduce the dimensions. Say we have lots of features, we want to take say top 10 features or top 2 features, it depends. So whichever has the highest variance, like the features which gives us the highest variance will be selected in PCA. Okay, so the problem statement would be we want to find a direction, say f1 dash, and f1, f2, f3, these are the features. So we want to find a direction f1 dash such that the variance of xi's, which are the data points, projected into the f1 dash is maximum. So we so this is a pretty simple problem statement which I have said, and this undergoes a lots of calculation of covariance matrix, then calculation of eigenvectors, eigenvalues, vectors, then normalized eigenvectors, and then plotting. So we'll go one by one in this video. Okay, so basically if I want to tell you in short, so if this is the axis, okay, and we can see that let me draw both the features eigenvectors first. Okay, we'll get a eigenvector like this which are 90 degrees to each other. Okay, so this is vector 1, this is vector 2, this is corresponding to the feature 1 say, and this is corresponding to feature 2. So if this has got a lot of points here, so this everything when projected to this line, so we'll have a high variance, okay, rather than in this part. Okay, so we'll have less points, so less information will be written from this one. So this has got lesser variance. So yeah, let's take a problem and then try to solve it using PCA. Okay, so let's take a problem in hand. So we have a problem in hand which is let's say we have two features x1 and x2. Okay, so x1 has points like 4, 8, 13 and 7, and this has got points like 11, 4, 5 and 14. So this is what we have. Okay, and we have two features here. So the problem in hand would be, given this following data set, you have to use the PCA to reduce the dimension from 2 to 1. So here we have x1 and x2 are the two features. So let's start. Okay, so the first step would be to calculate the mean of the variables. So what we have is the number of features. Okay, I'm sorry, the number of features here n is equal to 2, and number of data points, that is n equal to 4. This is number of rows. Okay, so n equal to capital N equal to 4. So if you find out the mean of x1, so x1 dash would be 4 plus 8 plus 13 plus 7 divided by 4. So 32 divided by 4 is equal to 8. Okay, and x2 dash, this will be 11 plus 4 plus 5 plus 14 divided by 4. So this will give you 8.5. So so we have calculated the mean of x1 and x2, which are the two features in our data set. So next step would be to calculate the covariance matrix. So let me write this down. Okay, covariance matrix calculation. So first we have to find out the ordered pairs. Okay, so what are the ordered pairs? Sorry, so ordered pairs of 2, so x1 and x2. So or we have to find out the ordered pairs out of this x1 and x2. So those are x1 x1, x1 comma x2, x2 comma x1, x2 comma x2. So these are the ordered pairs. So we can see that we have got 4 ordered pairs. Okay, since n is equal to 2, so the number of ordered pairs will be n square, so this is 4. Okay, so now what you have to find is, for each ordered pair we have to find out the covariance. Okay, so what we are going to do is, let's see, so ordered pairs of covariance, so covariance of x1 comma x1. Okay, so if we just look at the formula. Okay, if we have x1 comma x1, so we'll have this one as 1 minus n minus 1, 1 divided by 1 minus 1, summation of I is equal to 1 to capital N, and this will be x1 minus x1 bar whole square. So if we substitute this formula here, so we can easily calculate this out. Okay, so covariance of x1 comma x1 first. Okay, so we will get 1 divided by 4 minus 1, okay, multiplied by 4 minus 8 square plus 8 minus 8 square plus 13 minus 8 square plus 7 minus 8 whole square. So this is what we got. Okay, 4 8 13 7, 4 8 13 7, and these are the mean of feature x1. Similarly, if you calculate this, you will get 14. Okay, so similarly you have to calculate the covariance of x1 comma x2. Okay, and if you just substitute this into this formula, okay, so we will get minus 11. Then you have to similarly calculate x2 comma x1. So this will be same as covariance of x1 comma x2, which is minus 11 only. Then we have to finally calculate x2 comma x2, the covariance of this one. This will come as 23 if you put this into this formula. Okay, these two will be going to this formula, and this will be going to this formula. So yeah, after calculating this, you will get this as output. Okay, 14 minus 11 minus 11 and 23 as the covariance of each ordered pair. Okay, so our covariance matrix is 2 cross 2. This is a square matrix, like equal to the number of features. So we have 2 features, so 2 cross 2. So this will be equal to the covariance of x1 comma x1. So it will be 14. Covariance of x1 comma x2 is minus 11. x2 comma x1 minus 11 and 23. So this is our covariance matrix, which I have find out in step 2. So next step would be next step. Okay, so this is the calculation of eigen values. So after calculating the covariance matrix, we'll find out the eigen values. Okay, so what we have is the formula of determinant of s minus lambda I is equal to 0. Very simple. So we'll have this determinant of we have s as 14 minus 11 minus 11, and this is 23, a matrix, and minus this will be I is the identity matrix, so 1 0 0 1. Okay, so this will be minus lambda 0 0 and lambda, so this will be equal to 0. So determinant of if you do this, then it will be 14 minus lambda, this will be minus 11, this will be minus 11, and this will be 23 minus lambda. This will be equal to 0. Now if we solve this, we find a determinant, then this multiplied with this minus this multiplied with this is equal to 0. So this will form 14 minus lambda multiplied by 23 minus lambda, okay, minus 11 into minus 11 is equal to 0. So this will be a quadratic equation, that is lambda square minus 37 lambda plus 201 is equal to 0. So here if you use the Sridhar Acharya's rule, that is we'll get a equal to 1, b equal to minus 37, and c is equal to 201 here. So we have got the values of a, b and c, and we have to substitute this into this formula. Okay, let me write it in red. So here the lambda is equal to minus b plus minus root over b square minus 4ac divided by 2a. So one with minus and one with plus, so you will get two values. Okay, so if you substitute this, you will get lambda is equal to 30.3849 comma 6.6151. if you substitute, then you'll get two values here. Okay, so this will be lambda 1, this will be lambda 2, and we can find out that lambda 1 is greater than lambda 2 here. Okay, so we will declare lambda 1 as our first principal component, okay, PC1. And now what we're going to do is we will be interested more on eigenvector of lambda 1. Okay, so next step would be calculating the eigenvector corresponding to the eigenvalue of lambda 1. Okay, so our next step would be calculation of eigenvector. we have already found out the eigenvalues, and we saw that lambda 1 is greater than lambda 2. Okay, so now next we have to find out eigenvector corresponding to the lambda 1. So we have formula like s minus lambda 1 into I, and u1 multiplied by u1 is equal to 0. Here u1 is equal to a 2 cross 1 matrix with u1 and u2 small u's. Okay, this is 2 cross 1 matrix. This is the eigenvector that we are gonna find out, and it has got both magnitude as well as direction. That is why it is a vector. Okay, so next if we substitute this one, so we'll get 14 minus lambda. Here it is minus 11 minus 11 23 minus lambda into this u1 and u2, okay, is equal to 0. So if we find out, if we calculate this, then what we'll get? So we are gonna get 14 minus lambda, okay, multiplied by u1 minus 11 u2, and this will be minus 11 u1 plus 23 minus lambda 1. This will be lambda 1. Okay, so lambda 1 into u2, okay, this will be equal to 0 0. Okay, so if we solve this, then we are gonna get 14 minus lambda 1 multiplied by u1 minus 11 u2 is equal to 0. Okay, and minus 11 u1 plus 23 minus lambda 1 into u2 is equal to 0. These are the two equations. You can solve this, and after solving this you can find out, like if you use approximation method, then u1 by 11 equal to u2 by 14 minus lambda 1 is equal to t, say. Okay, and if you put like t is equal to 1 here, then we'll get u1 as 11 and u2 as 14 minus lambda 1. So this part, so we have got this part. Okay, okay, so as we can see here, we have got u1 as 11 and u2 as 14 minus lambda 1. So this is the eigenvector capital U1, which is corresponding to the eigenvalue lambda 1. Okay, so next what we are going to do is we are going to substitute the value of lambda 1 into this. So what we'll have is, so eigenvector, okay, u1 of lambda 1, okay, is equal to, this will be 11 and this will be 14 minus lambda 1. So this is 11 and this is 14 minus, what we have got is 30.3849. we have already calculated this before. So 11 and this is minus 16.3849. so we have got the u1, the capital U1, and this is the eigenvector. So next, what the next step would be to normalize it. Okay, so we are going to find out, we are going to call this as unit eigenvector or normalized eigenvector. Okay, so let's E1, okay, E1 is equal to, we have 11 divided by, we have 11 square plus minus 16.38 square. Okay, and here we have minus 16.38 divided by 11 square plus minus 16.38 square. Okay, so if we calculate this one, we will have 0. Let me rub this first. Okay, so we are gonna have 0.5574 and minus 0.8303. so this is our normalized eigenvector corresponding to the eigenvalue lambda 1. Okay, similarly, if you calculate the eigenvector corresponding to the eigenvalue lambda 1, then you will get E2 as 0.8303 and 0.5574. You can use the same formula to calculate this, but similarly, like this E1 and E2, if you plot this two, then you can find out that they are like 90 degrees to each other. Okay, meeting at a point. So we'll talk about this later. First we have to, the next step would be to derive a new data set. Okay, let's see that first. So the next step would be to derive a new data set. So derive new data set. So this data set would be PC1, the first principal component. Okay, and since we are like we had two features before, now we are converting into one, so we'll have one principal component. So this will be P11, P12, P13, P14. So we need all these points. So how will we calculate this one? So P, we have a formula called P is equal to E transpose into X minus X bar, say X1, and X2 minus X2 bar. So these are the mean and these are the data points, and this is the normalized eigenvector. So similarly, if you just substitute this, we'll get P11 value is equal to, so E1 transpose is 0.5574 and this is minus 0.8303 multiplied by what we have is 4 minus 8 and 11 minus 8.5. okay, here we can see that 4 and 11, and corresponding mean is 8 and 8.5 for x1 and x2. So similarly, if we find out for P12, okay, so this part will be same and this part would be 8 minus 8 and 4 minus 8.5. So similarly, you have to calculate all for P13 and P14. So after calculating, we'll get this as the result. Okay, will be equal to PC1. We have got the values. If we calculate all those, and then we'll get minus 4.3052, 3.7361, 5.6928, and minus 5.1238. These are pre-calculated. You can, if you just substitute in the formula, you will get the same values as well. So this is the we can see that we have reduced the dimension from 2 to 1, and this is the only principal component 1 we are getting here. Okay, so this is really awesome, and in this direction you will get the maximum variance. Okay, so if we plot this, okay, so if we are gonna plot this, then let's draw the y-axis, the x-axis. Okay, and let's do 4, 6, 8, 10. Here 2, 4, 6, 8, 10. Okay, and we'll take the mean. Okay, that is 8 and 8.5. So we have 8 here, and we'll get 8.5 somewhere here. Okay, let's mark this for our first principal axis. So this will be the center of the principal axis 1. So here we'll get, okay, so this is 2, 4, 6, 8, 2, 4, 6, 8. Okay, and this will be 0. So next what we are going to do is we have E1 as 0.5574 and minus 0.8303. we are going to plot this one. So 0.55. okay, so this is 1 and half of that will be this one, so 0.55 here and 0 minus 0.83. so if we extend this, this is 2, this is 1, so somewhere close to this one. So this is the point we want. Okay, so we will be drawing a line touching this. Okay, and we'll name this one as E1 cap. So this is the direction, and similarly if we plot E2, which was 0.8303 and 0.5574, if we plot this, we'll get somewhere around this point, and just sorry, but not going to the middle, but yeah, so this will be 90 degrees. okay, this will be 90 degrees and this will be E2 cap. So yeah, here you can see that if you plot all these points like minus 0.43 and 3.76, all these will lie here only. Okay, on this line. So yeah, we have successfully plotted this thing, and we have reduced the dimension from 2 to 1, and we can always see that this part will have the maximum variance. Like if you converge all the points here, then all it will have the highest variance than this feature. Okay, this will have lesser ones, and this will be 90 degrees. So yeah, so this is all for this video, and I hope that you got this problem. And sometimes it is asked in the interviews as well, like they will give you a data set like I have given here, and they will try to like make you calculate say covariance matrix, like not the entire thing, not the entire PCA, because obviously if in the day-to-day task you will be using PCA library, right? In Python you get that easily, so that is not needed. Just the basic understanding of PCA and how it is happening, and like given a data set, how to calculate this covariance matrix, then from covariance matrix how to like a simple formula for eigenvalues, simple formula for eigenvector as well. And yeah, so that's it for this video. If you like this, please share the video. That is the most important. Just don't keep the knowledge to yourself, just share it among your friends. Like and comment, and like comment the stuffs which you did not understand in this video. Like if you want some more clarification, then I probably will make another video on this. So yeah, please, if you have not subscribed already, please subscribe to my channel, and you will get all like more videos and good stuffs on this, like interview preparation stuffs and modern state-of-the-art algorithm stuffs and all. So please go through my channel and subscribe and hit like. Thank you. Bye bye.